Hello everyone, my name is Sudheer Kumar, working as an assistant professor of mathematics in MLR Institute of Technology. Last class we have seen non-exact methods and to find the integrating factor. In this lecture I am going to cover this Newton's law of cooling and problems based on this. Let us see the statement of this Newton's law of cooling. It says that the rate of change of temperature of the body is proportional to the difference between the temperature of the body and the surroundings medium, that is room temperature. So let us see this. Let theta be the temperature of the body at any time t and theta naught be the temperature of the surroundings. So by Newton's law of cooling, the rate of change of temperature, rate of change means d by dt of theta, that is d theta by dt, is proportional to the difference between temperature of the body and surrounding medium, that is theta minus theta naught. So if I remove this proportionality constant, I can write this as minus k, because the temperature gradually decreases, so I can introduce the proportionality constant minus k. Suppose if the temperature is increases, we can keep the constant plus k. So here d theta by theta minus theta naught is equal to minus k into dt. So here theta terms and t terms separated, variable separable, we can integrate both sides. So we get log theta minus theta naught is equal to minus k t plus c. From this I want value of theta, that gives the temperature of the body at any time t, right? So this can be written as initially means at starting time, so at t equal to 0, theta is theta 1. So if we substitute theta 1 in place of theta and t equal to 0, so we get c value as log theta 1 minus theta naught in this value. So log, in place of theta I am writing theta 1 minus theta naught is equal to minus k into t is 0 plus c. So c value we get log theta 1 minus theta naught. This c value you substitute over here, so we are getting this differential equation. So take this log to this side, that becomes log theta minus theta naught minus log theta 1 minus theta naught is equal to minus kt. So this is log a minus log b can be written as log a by b, that equal to minus kt. So if I remove this log, right side it will become e power minus kt. So from this equation, theta minus theta naught can be written as theta 1 minus theta naught into e power minus kt. I want only theta value, so take this minus theta naught to right hand side. So this gives theta value theta naught plus theta 1 minus theta naught into e power minus kt. This gives the temperature of the body at any time t. So we are interested in finding the temperature of the body at any time t. This is how we find. Now let us see the problem on it. A body is originally at 80 degrees centigrade and cools down to 60 degrees in 20 minutes. If the temperature of the air, that is room temperature, is 40 degrees, then find the temperature of the body after 40 minutes. So by Newton's law of cooling, here theta is the temperature of the body, which is initially how many, 80 degrees centigrade, and theta naught is the room temperature or a temperature of the surroundings, which is 40 degrees centigrade. So by Newton's law of cooling, we can write that d theta by dt is equal to minus k into theta minus theta naught, separating both sides the variables and integrating. So we get this equation. Here initially means time t equal to 0, at a time t equal to 0, what is the temperature? 80 degrees. So at a time t equal to 0, theta is 80 degrees. So substitute that in this equation 1. So we get this equation, that means if I remove this log theta minus 40 by c equal to minus kt, so theta minus 40 by c equal to e power minus kt, this is the equation to find the temperature of the body at any time t. Now what else is given? This temperature is cools down to 60 degrees in 20 minutes, means at a time t equal to 20 minutes, theta is 60 degrees centigrade. So if you substitute in the equation 1 t equal to 20 and theta equal to 60, so we get this c value, and at t equal to 20 theta value is this value. So from this equation I am getting the constant k value. So if you solve these two, we are getting k as 1 by 20 into log 2. Now what is asking in the question? After 40 minutes what will be the temperature of the body? After 40 minutes means when time t equal to 40, this equation 1 can be written like this. In this I am substituting the value of k. So 40 plus 40 into e power minus 2 into this log 2. So this can be minus 2 log 2. If you substitute this value, I am getting theta as 50 degrees. Means after initially from 80 to 60 degrees it took 20 minutes. Further 60 degrees to 40 degrees after 40 minutes. After 40 minutes, how much this will be the temperature of the body, that he is asking. So that temperature of the body after 40 minutes will be 50 degrees centigrade, right? Let us see one more problem. An object whose temperature is 75 degrees, initially the temperature of the body is 75 degrees centigrade, which cools in atmosphere at a constant, that is room temperature or temperature of the surroundings is 25 degrees centigrade, theta being the excess temperature of the body over the temperature. If after 10 minutes the temperature of the object cools down to 65, means 75 to 65 degrees centigrade, it cools down after 20 minutes. Also find the temperature which is required to cool down to further 55 degrees centigrade. In how many minutes, how much time it will be further reduced to 55 degrees centigrade? This time we have to find. There are two cases. Time will be given, temperature we have to find, or temperature will be given, we have to find the time. Here we need to find the time also. So initially we will take 1 minute unit of time. So d theta by dt equal to minus kt. So from this equation theta is equal to c into e power minus kt. Initially starting time at t equal to 0, we have given theta is 75. So 75 minus this 25 is theta, that is 50. So we got c value 50. So substitute c value 50 here, we get theta equal to 50 into e power minus kt. When t is equal to 10 minutes, the temperature is 65. So it is 65 minus 25, that is 40. Substitute 40 here in this equation. So we get 40 equal to 50 into e power minus k into t. T means 10. So e power minus 10k. So e power minus 10k value is 4 by 5. Let us keep it aside. Now when the value of theta when t equal to 20, theta is equal to c value is 50 e power minus k into t. K into t means what? 20. So e power minus 20k. So theta value is 50 into, here we get e power minus 10k value as 4 by 5. So this e power minus 10k whole square means 4 by 5 whole square, right? Now when t is equal to 20, theta is 32. So 32 plus 25, that is 57, when the temperature of the body is 55 degrees centigrade. 55 minus 25 is 30 degrees. Now let us find the time. So let t be the time required. So theta is equal to, that is 30 degrees equal to c into e power minus kt. C value is 50. So 50 into e power minus kt. Let us be equation 4. So from the equation 3, e power minus 10k can be written as e power minus k whole power 10, that is equal to 4 by 5. So e power minus k can be written as 4 by 5 whole power 1 by 10. So 30 equal to 50 into e power minus kt. From this equation, 30 equal to 50 into e power minus kt value 4 by 5 whole power 1 by 10. So 4 by 5 whole power 1 by 10. So from this equation, take these two terms aside. Log a minus log b can be written as log a by b. So log 3 by 5 divided by log 4 by 5. If you enter this value in your calculator, we get this result. So the time required to further reduce is 22.9 minutes. So within 22.9 minutes, the temperature cools down to 55 degrees centigrade. Thank you.